All right, we can get started. Why don't we start with Mayor today?
Oh, okay. My first reaction was that Earth is a complex system, but not a distributed system. I mean, obviously, it can be both. Because in I don't know, my intuition is that distributed systems have more standalone components, that work quasi together. So there's some sort of lines of communication between them. So, more if we look at Earth and the Moon, that's more of a distributed system, except nothing's happening on the Moon. But there are definitely distributed systems inside the Earth. And I looked at the following 3 pages: biogeochemistry, system geology, and ecosystem ecology. The biogeochemistry was underneath one of the geo something links. Some of the links are short. And what I like about biogeochemistry is, I guess, what Darwin liked about how big things can happen from very small mechanisms. So oxygen is created by these bacteria, and suddenly it poisons most of the existing life on Earth, and it causes oxidation of various compounds. At the same time, having reducing bacteria can reduce minerals, which in the natural state would want to be oxidized. The concept of wearing down of rock and how that can affect the levels of CO2 in the atmosphere, as a way that coral reefs, okay, so it's biogeochemistry, coral reefs can put out chemicals which encourage cloud formation, which gives them more shading and protects them against heat and direct sun. So all of these interactions between the biology and the chemistry of geology, I think, is very interesting and sometimes surprising. Right now, we have melting of Siberian permafrost causes release of methane, which of course will feed bacteria and also heat the earth. Um, the subject of system geology, what I like about it is that it's happening really, really slowly in general. For example, you have mechanisms which create mountains, like the Andes, and these mountains affect the weather. And when you affect the weather, you get a lot more wearing down of soil, like in the Amazon, and much less in the desert on the west side. Or you have uh, Pagana, this giant continent. And if you have a giant continent and there's no rain, so geologically the rain isn't doing anything. But at the same time, you also have sometimes some very fast mechanisms like landslides. And right now in California, they're having simultaneously rain and earthquakes. And I've seen studies talking about how rain and low pressure systems, like you have in hurricanes, can encourage faults to give. And last but not least is ecosystem ecology. And in ecosystem ecology, I definitely see more of a distributed system. First, each animal or plant is acting on its own, but you also have classical distributed. You have whales traveling several thousand miles, and when they do that, they bring food from one place to another. And when you have whales dying, they bring food to the bottom of the ocean. You have migrating birds bringing diseases from one place to another, and you have fish which can do a lot of traveling. And I was just in Scotland, and they have a drought, and because of the drought, the level of water in the Ness River is lower, so the salmon can't make it up from the ocean into Loch Ness. Okay, so that's an interesting combination of geology and biology, and it's happening in multiple places at the same time. So that is my take on complex Earth. And I guess I'm passing it on to Venkatesh.
All right. So, yeah, I didn't think too much about the definitional aspects. I think a complex system like the Earth, depending on the perspective you adopt and I guess certain tuning knobs, it can behave in highly distributed versus highly centralized ways. So yeah, Pangea, the continent, that's a very clear physical example. At one point, there used to be one big, massive continent, and at some point, it broke up and became like seven different land masses. And that was an example of a phased change knob going from centralized to distributed because they're still kind of coupled geologically. Um, and similarly, I mean, if there's a lot of international trade, the human part of the biosphere is extremely connected, and an economic crisis in Japan can affect the economy in America. But historically, when trade was like under 2%, economies were much more decoupled, and then you could say it's more distributed. So I guess you can say that this is a higher level system than either distributed or decentralized or centralized. It has parameters that if you tune them, it can behave as any one of those things. And one of the interesting things is if weather systems are in a particular sort of like high energy catastrophic state, lots of things get coupled. So the reason I thought of this at all was um, last night I was Googling stuff about weather because lots of interesting things are happening on the US West Coast right now. LA has a hurricane which is extremely rare on the Pacific side. Like the last one was about 30 years ago, apparently, and there's only a few a century. Whereas on the Atlantic side, there's usually a half a dozen of various sizes per year. And I was wondering why that is. And it turns out usually big storms in the Pacific, they go out towards the ocean. And this year, what's happened is because of the extreme heat domes and the heat waves in the continental part, there's I guess, a pressure gradient that's sucking the storms that normally go out to the ocean towards the land. So we have a rare West Coast hurricane in the US. And also, there was an earthquake yesterday in LA. I'm not in LA anymore, I'm in Seattle. But there's an earthquake in LA, 5 pointer, so reasonably medium sized. And it was an interesting confluence of like two emergencies coinciding. So a hurricane plus a medium-sized earthquake. So that was interesting because emergency services had to respond, and normally those are decoupled. Like you don't usually have like extreme weather and earthquake risk at the same time, but increasingly we are having that sort of thing. So here where I am in Seattle right now, there's a couple of big wildfires raging as well. And of course, this is also an earthquake and volcanic risk zone. Mount Rainier is an active volcano, even though it's not exploded or erupted for a while. And this is one of the biggest earthquake risk zones, except unlike California, which has lots of smaller frequent earthquakes, Pacific Northwest uh, is at risk of like a really big earthquake every 200 years or so. So um, point is, all these systems, I guess, depending on what scale you're looking at, they're either decoupled or coupled. So most of the time, you can go around in a very decentralized life, living in your corner of reality, looking at what you're looking at. But sometimes you get powerful reminders that everything is super coupled. Anyway, I was reading that page because when I was clicking through yesterday, I found it and I was like, uh, I thought I knew what earth science is, and that was the field that existed when I was in college. People used to study earth science, but this called itself earth system science. And then as I clicked more, it became clear that this is some sort of relatively modern, somewhat bureaucratic mix of like I don't know, political agenda machine with NASA plus UN type bureaucracy plus an actual academic field, and it goes back to the International Geophysical Year in the 1950s. So it seems like all these really complex systems where lots of government interests are involved, you end up creating something that doesn't feel quite like an academic science, but also doesn't feel like engineering or a government like regulation agency. It feels like something in between. So anyway, I was reading thing. I read the main page, then I read part of the original NASA report in 1986 that apparently triggered this thing. And I was trying to like click around finding out whether this is just like a shallow thing that people are trying to make happen, or whether it's a major thing with lots of funding and meaningful things happening. So it looks like it's meaningful. So apparently, the term Anthropocene was popularized by people behind this field, including things like tipping points and so forth for Earth stuff. And clearly, it's like very political. It's a field that's been invented mainly to, I don't know, shape discourse on climate change. But yeah, I also read part of the biosphere stuff as it relates to the system science stuff. And I was reminded of earlier stuff I've read about just how important life is in shaping like the larger uh, non-living part of Earth. So I forget where I read this. There was a Nature article or something, but something like I don't know, a huge percentage of the Earth's minerals are involved in like a biologically driven cycle. So lots of I don't know, complex mineral crystals depend on life existing, and of course some major cycles like nitrogen, phosphorus, and of course oxygen, all are driven by life. And there's also, I think I read this somewhere else, so I'm sort of going all over the place here. But apparently, you can only have life if there are plate tectonics, because a certain like basic mineral cycles, like carbon and nitrogen, they can't exist unless you have an active tectonic system. So without earthquakes and volcanoes, you basically cannot have life, which is kind of interesting because we think of earthquakes and uh, volcanoes as basically dangerous, and even though they're like exciting, it would be convenient not to have those risks around. But apparently, you can't have life without them. But anyway, yeah. So this was kind of like I don't know, fishing expedition in a whole new territory, and yeah, I think there's a lot here. Oh, and the one other thing I found out was in the unpaywalled version of the thing. Anuraj posted, it mentioned something called the Brotherton diagram, but it wasn't in the paper, so I went Googling, and it's an interesting diagram. I'll post it. It's kind of like, it looks like UN bureaucrats made it, but it looks actually quite interesting. So that's me, and then passing on to Anant. Anant, are you able to speak? All right. If not, let's pass on to Ben and circle back to Anant.
Hello, can you hear me? First time using this, whatever it
Yep,
is,
we can
StreamYard.
hear you.
Um, yeah, so I mean, a question. I don't know if I have a lot of coherent thoughts on this, but I do think is Earth like a distributed system in the same way like so many of these computer networks try to be, and I think I can definitely see either how it would work that way. It's interesting most of the time when you deal with distributed systems, because you're dealing with human constructs, there's very well delineated, abstractions between different components. Like you'll have a computer here, and that's well defined, and it's communicating over I don't know TCP or something. and to this other computer there, which is well defined and not the first computer. And in some sense, the Earth is that way. You have this continent over here, and you have this island over here, and they're pretty separate. But I mean, the atmosphere is very much one big thing circling around. So the sort of clean abstractions when you get to the natural world start to dissipate, and it's very hard to see whether you're looking at sets of systems or one big system. So, and because humans work hard to make our technology and such, conform to good abstractions, whereas nature has no such compulsion. Yeah. So, and how humans interact with this, big global environment, since now that technology has improved, the Earth has effectively gotten small enough that we can really talk about human Earth interaction as a direct thing. Whereas I think historically there was obviously people had their local environment, but humanity was neither controlled or big enough to really have to be human and Earth. It's more like people living in an area, maybe they deforested it, or maybe weather's bad, and so on and so forth. But in the last century, humanity has gotten big enough that you can talk about human and Earth, and I feel like on the various different sides of this sort of modern, with climate science and all the stuff that goes on with that. Well, I guess I'm not sure what kind of point I'm trying to make. I feel like there's humans, or the discourse around this tends to always want to shift the entire sort of thing into one of the very preset abstractions. Thinking about it in terms of abstraction boundaries, like either humans are in full control of themselves and are acting on the environment, and you model the system as all right, human interaction on the environment, with very little thought of how the environment interacts back on humans. I mean, they think about it physically, but not really psychologically or politically. How does the environment influence human politics? And people often don't like that framework because it implies the less agency for humans if they're the effect instead of the cause. But I think an actual, I don't like the word holistic, but holistic, viewing humans and the environment together. I don't know. I'm blabbling at this point. I'm not sure there's any point here. And thinking about it in terms of a distributed system. Maybe you would have humanity as a node and the environment as a node, but they would be a node that's almost like virtual private systems sharing resources together. Not an easy thing to model. Anyway, I think I'll move on. Are we going down to the bottom? I cannot see the name. Sachin? Or do you want to head back to Ananth?
Let's go to Sachin and Sachin, and then come back to Ananth at the end.
Cool. Yeah. The pages I went to was global change, which I guess describes sort of like how changes in Earth systems is sort of non-linear and happens sort of very fast. As in, almost feels like things happen slowly for a while and then all of a sudden and affects the whole system. And I guess with respect to distributed systems, I was thinking a lot of the systems that we have, once they are functioning, they sort of fade into the background and you don't really think about them. So you don't like, unless you are deep working in the field, I guess you wouldn't think about how the system is changing. And even I think if you yeah, I guess even if you work within a distributed system, those things are hard to consider because you get used to a specific paradigm, I guess, and so like large changes that may be around the corner, you may miss out on because you're used to a specific way of thinking. And yeah, and I was yeah, so I guess it reminded me of the reading that we had in online governance, the Shrine of Issei Jingu, which was about this Japanese shrine that gets rebuilt every 20 years. So basically, the old shrine gets destroyed and a new one gets rebuilt in its place every 20 years. And I guess that is a system that allows people to like pay more attention to how things are changing, like how the environment around them is changing, how the materials needed for accomplishing a particular thing is changing, etc. And I guess yeah, so and I guess we have asked this question in online governance also, like how can that be done with respect to like other human systems and distributed systems. So yeah, that and yeah, and I guess similar to what Venkat was talking about with respect to climate events, like I guess it also, especially psychologically, it feels the same way where people don't pay attention to it for a while because it's in the background, and then the changes happen really suddenly, and everyone seems to be caught off guard, or existing systems don't respond enough to the speed at which changes happened. I guess I was reading about the Hawaii wildfires and how the alarms, and I guess Hawaii has a pretty robust warning system because of tsunamis and World War II and everything, but none of the warning systems went off for the fire, and nobody's able to tell why. If it's and the current hypothesis is the fire was like so fast that nobody even got time to give warnings. So like, what do you do? How do you prepare for something like that, or like what do you do in those kind of cases? Yeah, and also yeah, I guess it's also interesting to like think about like in like agency of each individual part in a system also, and this is like with respect to emergency systems and stuff, like for example, like a lot of people have Amber Alerts on their phone off because it's annoying, but then so it's like, but then like a lot of warning systems is designed around the presumption that people would have it on. So I don't have further thoughts on that, but that's an interesting thing that I was thinking about, like how do you deal with individual agency within a system like that. Anyway, those are my thoughts. And
thank you. Yeah, well, I read the primary Wikipedia page, and for some reason, my mind or my eyes just kept getting stuck at economics and the ecological economics as like two categories that was almost felt like an odd one out of this the other topics that was part of this page, which was more in some sense science in a way that it's naturally occurring phenomena that we are trying to observe and quantify, versus the economics is like a man-made, socially created story. And it seems sort of odd to mix those two things uh, in that earth system science, in that it at least it seems to me that it might be we may not have like a good holistic view of it in terms of quantifying the effects as like causation as correlation type thing, because I don't know, it seems like there is a lot of conflation that goes on because of economics being an important parameter in observing natural earth phenomena. And yeah, I mean, and also I always I link the prompt as to I like the prompt as to the question of whether Earth is a distributed system or not, and it's it's there are examples that occurred to me when I was reading the prompt as to that maybe point to if Earth has some way of natural mechanisms of healing, or not healing in some sense, but it's sort of natural cycles that happens irrespective of sort of human impact on those cycles. And I was wondering if how much of that effect is due to human impact. And I ran into this Wikipedia page. I'll share the thing called wildland urban interface. Apparently the wildland urban interface is like a zone between wilderness and like the sort of land or area, urban area that's human developed. And that area was like that interface was the largest growing segment of all land areas apparently between 1990s and 2010s. Has since gone down, but it sort of made me think about whether if that type of interface is like an like urbanization is some sort of like an API to Earth, in that we build our built environments within those areas without affecting the rest of the Earth's ecology. I mean, I don't know what I'm saying now, honestly, but anyway, those are some meandering thoughts that that I had. I was just clicking around, but I'll stop there.
So yeah, Anuraj, I think you're the only one left. If you could unmute and join.
Yeah, so I quickly went through the article, and the definition of Earth as a distributed system, like I don't know if it applies to it or not, because it's more like a complex system, and then a lot of the parts are like mixed with each other, and yeah, so like I don't know if it can be modeled as a distributed system. And then about this field itself, it seemed like a made up field. I don't know. It reminded me of one of the talks by Alan Kay, in which he talks about the science envy, and gives examples about fields which have to add science to their name so that feel like science, and then gives an example of computer science. To some extent, it feels like that. Because like today many of the software or systems we build, people try to apply some sort of scientific method to it, but a lot of it's like most of the times people working on it basically don't know how the software will react, or so it's like, yeah, it seems something similar to that, adding science to the name so that it feels sciencey, but I'm not sure if it's really some sort of science or not. And yeah, I don't know why it reminded me of the Ethereum virtual machine. Maybe not even related, but yeah, those were some of my thoughts.
Yeah, floor is open for more comments.
Yeah, when listening to the other people talking, I was wondering if Earth system science is not an opportunity to teach people about complex systems and about distributed systems. Uh, because, first of all, we have examples that are open to all. There's a lot of data. Some of the data can be easily absorbed. And I'm just wondering if it might be a way to educate people, because obviously people do need to be educated in what these two things are, in complex systems and distributed systems. So that's what I was thinking.
So one of the things about this type of like messy subject is that it's tempting to get into definitional debates, but usually I'm not too concerned about them unless it kind of like leads to some interesting distinctions. So here we are talking about distributed versus complex as one distinction, and a science versus a not science as another, and whether or not this is an engineering field or not. And in a way, I don't know, I find it hard to get worried about any of those things. I think the question I focus on is this particular frame pointing at things that otherwise we tend to miss or ignore completely? Is it like pointing at like things that fall through the cracks? And is it asking, is it allowing us to ask and answer interesting questions? And I think in this case it is. I also initially got the sense Anuraj did that this is a made up science. And to some extent it is. It's clearly made up by a bunch of like governance and bureaucrat type people rather than actual scientists, and they attach the name science to give it a certain kind of credibility. But that doesn't mean that it doesn't point to something interesting and useful that nothing else points to. So if you look at the most adjacent thing, which is earth science itself, I think, is sort of like a geology plus plus. So the oldest version of this kind of field used to be geology. And I think at some point somebody decided to call it earth science to make it slightly broader by, I guess, attaching meteorology and a couple of other things. But I think what I like about this is it really highlights the interaction of natural and artificial systems, living and non-living systems, and the idea that if you have enough agency and power, you can actually treat it as an engineering domain as opposed to just a descriptive natural science domain. So, and we're getting there. We have like we can do solar geoengineering now, albedo alteration. We can pump stuff into the atmosphere. So at that point, it suddenly stops being any kind of natural science and becomes a kind of engineering, whether or not it's like decoupled enough to do properly disciplined engineering of the sort Ben is talking about with like clean abstractions and stuff. It kind of doesn't matter if somebody at some point in the next 20 years decides to like pump stuff into the atmosphere to like alter the albedo, whether or not it has the clean boundaries and system diagrams of an engineering artifact, we are going to be engineering with it. So it's kind of interesting. And I really liked the point Anant made at the end of maybe cities are a way to almost create APIs of the earth, because you've got this underlying extremely complex and dynamic thing that under certain circumstances behaves distributed and other circumstances behaves centralized. Sometimes it has like engineering like lawful behaviors, other times it looks extremely chaotic. But the city is kind of like a limited intervention. So you can think of it as your concern is not all of Earth. Your concern is, for example, Los Angeles. And again, going back to what inspired this yesterday, this whole line of thought yesterday, somebody on Blue Sky made a joke like, because there's an earthquake and a hurricane happening at the same time, if Godzilla were to suddenly come up from the ocean and attack LA, it would be extremely funny. And I thought that was really funny. That's why my profile picture right now is Godzilla. But this is on the religious side. Mythologies like Godzilla in modern times are actually sort of the religious version of Earth system science. When we find something so complex and hard to think about that we really kind of have to switch to literary and mythological modes to think about it, we come up with mythologies like Godzilla or Lovecraftian horror. And it gives us, and the reason we do that is it gives us a way to think about what we otherwise would not be able to think about. So I think Earth system science is an attempt to create like a non-horror Godzilla, and to limit sort of the scope and make it like tractable to think about. We tend to think about Godzilla like mythologies in the context of like the largest human concern areas where we have some agencies, which I think is actually cities. Like we may talk of countries and continents and the UN, but really the largest scale at which humans exercise agency is really large cities where you can like control the impact of like natural forces. So it's kind of interesting to think Earth system science, if you want a like more poetic way of thinking about it, it's the problem of thinking about cities versus Godzillas, where Godzillas represent the larger sort of complex system in all its like complicated behavior, and the city is the zone of your concern in the largest scale at which you can maybe defend it. And Earth system science is like the challenge of thinking about the interaction of the two. So I don't know, that's kind of like an alternative way of thinking of it. Couple more minutes. Any last thoughts? Oh, I had one more thought related to Godzilla. So it's interesting that Godzilla was invented as a mythology after Japan was bombed with nuclear bombs for the first and last time, hopefully. And it was kind of like a literary response to a very physical phenomenon. And there's a physical phenomenon version of it too. So there's Godzilla, the monster that's radioactive and comes up from the ocean. But an interesting related thing is non-radioactive steel. So to actually measure radioactivity, you need Geiger counters and other things made out of steels that have not been contaminated by radiation from like, nuclear testing around the world. And apparently the only way you can do that is to go and bring up sunken wrecks from deep in the ocean, from old shipwrecks that are steel ships that haven't been that was manufactured before 1940 or so, whenever the first atomic tests started happening, 1940 or something. I think it's called low background steel or something. So low background steel is sunken ocean steel, very short supply, extremely rare, extremely valuable, that's used to make things like Geiger counters, because the atomic explosions have sort of like contaminated all steel made since then, that we cannot really use it for making sensitive radiation instruments. So that's kind of funny and ironic that Godzilla, the radioactive monster, comes up from the sea, but also our main scientific sort of like material for measuring radioactivity also comes up from sunken old ships at the bottom of the sea. So there's some and a weird irony over there that it's interesting to think about. Yeah. All right, 2 minutes.
So I do want to talk a bit about radioactivity, because you made me think of it, because radioactivity is fascinating in that there's a huge distribution. Like you can detect radioactivity at very low concentrations, like above background. Whereas it's not actually that harmful for you until you get like, and there's an XKCD of radioactivity doses and so on, and of course high doses. It's like your cells are being hit by a machine gun, and that'll kill you pretty quickly. But and of course low doses increases chance of cancer and so on. But radiation is so fascinating, and the human reaction to radiation is so fascinating, because there's this huge range, effectively, of above background, but not actually that important. And because humans are so good at sensing it, because radioactivity is so easy to sense in some ways. Ionizing radiation, the Geiger counter is technically very, very simple, very simple device. You need the low radioactivity steel, But that's just, to keep, because it's so sensitive that you will detect your own steel in the device instead of what, the outside that you're trying to detect. And I think a lot of human interaction with nuclear energy, radiation, that sort of thing. I don't know. It's very, very fascinating psychology. I'm not sure if there's a lot of research done into this. It's because one of the things I think that's so critical is that it's so easy to detect above background, like in the nuclear accident in Japan, again, going back to Godzilla, I guess, the recent one in Fukushima or something. I don't know how to pronounce it. But, people were able to detect radiation in the water from that when they started, pumping, ocean water through it, like across the ocean. And it wasn't because, like, the entire ocean became a graveyard, or that, swimming in the seawater was going to, increase your chance of cancer by any significant quantity. It's just that it's so easy to detect these that you can see the tiny increase just from something happening all the way across a huge ocean. And it's just fascinating. Because, I figure if there was other parts that were that easy to detect, other contaminants in your environment, humans would act very differently. Whereas, radiation, very easy to detect. I think I've overshot my 2 minutes. So I've spent time pondering, what would it be like if radiation was much harder to detect, or other things were so much easier? Like you could detect, like, plastic pollution as easy as you could detect radioactive pollution. Would that change how we use plastics versus how we use nuclear energy and so on? I don't know. This is it's the very end of it, and I'm already talking about something different, so I'll end it here.
And yeah, I think there's some interesting bunny trails there that maybe we can get into in the future. Like, this was kind of like an initial survey session, but I think there is like interesting intuitions and inspirations to be found in this whole field. So maybe we can start like a track of readings inspired by this, and one of them might be radioactivity and Geiger counters and things like that. So I think there's something here, which is actually good inspiration for distributed systems in the traditional sense we've been talking about. So I'll think more on how to connect the dots and pick readings that illuminate the connection better. Oh, and yeah, the connection Anurag spotted of like the Ethereum virtual machine. The diagram I posted kind of looks like that kind of structure with, like, L1s and L2s and multiple levels of abstraction. So yeah, that's another connection we can explore. But anyway, we're over by a couple of minutes, so see you guys next week.